Alright, here's your Unit 3 test review. I'm going to try to refer back to the actual review more often so you see the questions. Number 1, what do you need to find the circumcenter? And the circumcenter is the same distance from what? What do you need to find the incenter? And the incenter is the same distance from what? To find the circumcenter, you are using the perpendicular bisectors, and the circumcenter is the same distance away from each vertex, from each point. The incenter is found using the angle bisectors, and the incenter is the same distance away from each side. What is the only factor that does not change with similar transformations? Similar transformations. The size changes. The angles do not. When you're changing something similarly, that's using a dilation, that means the sides are going to change, the angles are not. Number 3, list the corresponding parts of these two triangles. Corresponding means same location. So according to these two triangles, angle A is going to be congruent to angle D. Angle B is going to be congruent to angle E. Angle C is going to be congruent to angle F. And then with the sides, AB is congruent to DE. BC is congruent to EF. And AC is congruent to DF. Those are the corresponding congruent parts of those two triangles. Alright. 4, very easy question. Which one of these are not true? Which is not a congruent statement? We have side, 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 angle, side, angle, side, angle, 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 side, hypotenuse, leg. This one right here is not. If you write these forward or backwards, they should work. Therefore, side, side, side written backwards, side, angle, side written backwards, angle, side, side written backwards, hypotenuse, leg written backwards, angle, side, angle. The only one that when you write it the other way looks funny is right there. We do not have an ass as a triangle congruent statement. Angle, side, side does not exist. Neither does angle, angle, angle. Neither one of those are one of our 5. Alright. Number 5. Determine if there's enough information to allow you to create the triangle congruent to triangle XYZ. So here's XYZ. So I need to see if A, B, C, or D has enough information for me to prove one of these: side, 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 angle, side, angle, side, angle, 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 side, or hypotenuse, leg. A, triangle XYZ is, don't worry about that B, a right triangle with one angle measuring 30 degrees and one side measuring 12. If I follow those directions exactly, XYZ is a right triangle, so I have a right triangle. One angle measuring 30 degrees and one side measuring 12. Did they tell me where to put the 12? No. Did they tell me where to put the 30? No. So can I do that? Does that make sense to the directions? Yes. That is a right triangle with one angle measuring 30 degrees and one side measuring 12. Does that give me this triangle? No, because I was able to name my hypotenuse 12. The hypotenuse should be 24. So A does not work. B. If you have B, does that work? Well, according to the B, I have angle, angle, side, angle, angle, side. So that proves that this triangle is congruent to that one, angle, angle, side. XYZ is a right triangle. So let's draw another right triangle. I'm going to do this exactly how they say it. So you have a right triangle with, okay, X, Y, Z. XY is 12 root 3. YZ is 12. XZ is 24. Is that enough information? XY is 12. This one, although it looks like it's side, 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 it is not, because corresponding sides are not equal. So A and C are out. On a grid, anytime you see this, yes. As long as these numbers match up, which 12 would be this side, 12 root 3 would be this side, and you have 0, 0, which would be right there. So yes. So it would be B and D. Anytime you see on a grid, always on a grid, always, always, always. Which representations of ABC and XYZ can be used to prove that ABC is congruent to XYZ? Locations on a coordinate plane? Absolutely. This, if you look at this, this says angle, side, side. That's an ass. We don't have that. C, both triangles have an area of 16 units. What the freak? We never even talked about area. So no. We didn't talk about it, guys. It's not there. The last one, angle, side, angle, yes. Make sure it's also congruent to angle, side, angle. Alright, according to the diagram, what additional information is needed to prove the two triangles are congruent by angle, side, angle? We have to have angle, side, angle. Angle, that's easy. Those two sides. You need to know that BC is congruent to YZ. I'm going to do these two proofs on a different video. Number 10, let's classify the triangle. First thing you need to do is add all of them up. Triangle sum theorem. We're going to add all of them up. And to do that, we're going to get 6x plus 6x minus 90 plus 3x plus 30 equals 180. Triangle sum theorem. Add them all up, set them equal to 180. Combine like terms. You have 6, 6, and 3. So this is 12, 15x. You have a negative 90 and a positive 30, which gives you a negative 60 equals 180. Add 60 to to both sides, you get 240 equals 15x. Divide by 15. X equals, let's do this off to the side. 240 divided by 15 goes into 4 once. This is going to give me a decimal. 15 goes into 96. Is that right? So your answer 16, but you're not done. That's x. X equals 16. Now we got to take 16 and plug it in. So 16 times 6 is 96. The next one is 6x minus 90. We already said 16 times 6 is 96 minus 90. This just gives you 6 degrees. And I can find my third side by subtracting it from 180, or just by doing the math. 3x plus 30. 3 times 16. 48 plus 30 is 78. So my three angle measures are 78, 6, and 96. So it's not a right triangle. It's not an isosceles triangle. Here's my answer choices. It is an obtuse triangle because it is greater than 90. It is not a right. It's not isosceles. It is scaling because all angles are different. Alright, number 11. 7 and 15 are two side lengths of a triangle. Find all possible side lengths of the third. Triangle inequality theorem. Any two sides of a triangle have to be bigger than the third. My two sides they gave me are 7 and 15, not 17. 15. So to find all possible, you're going to have an inequality. You're first going to take 7 and add it to 15, which gives you 22. Then you're going to take 7 and subtract it from 15, which gives you 8. So all possibilities right here. Isosceles triangle ABC is created such that AB is congruent to BC. So this whole side is congruent to that side. I have an isosceles triangle then, which means this angle is congruent to that angle. Start labeling things as soon as you see them. Isosceles triangle, I know stuff about isosceles triangles. Those two are equal. Point X is placed between AB. Doesn't say in the middle, it just says between. And Y is between B and C such that XY, this is parallel to that. As soon as they're parallel, this angle equals that angle. This angle equals that angle. Let the midpoint of AC be E. So this is a midpoint. So this equals that. What can you say about triangle EXY? EXY is this. Since I've already labeled these two congruent, that means this is congruent to that. It's isosceles. Guaranteed, at least. Alright, D is the midpoint of AB. Now it says midpoint. E is the midpoint of BC. F is the midpoint. So this equals this, this equals this, this equals this. That means all of these are the mid segments. Find perimeter of parallelogram ADEF. And I just printed the other copy of this because it doesn't have the numbers. On your copy it says AB is 30. AB is 30. BC is 28. AC is 18. Alright, let's find the perimeter of ADEF. ADEF. Well, this is half, so it's 9. This is also half of the base, so it's 9. This is half of its side, so 15. This is half of the base, so 15. 15 and 15 is 30. 99 is 18, so 30 plus 18, 48. Done. 14. What is rigid motion and what transformations are considered rigid? Rigid motion is when you do not change the size or shape. You do not change the size or shape in rigid motion. Translation, rotation, reflection are all rigid. They're congruent transformations. They move one shape congruent to the other. 15. List the combination of transformations that will transform ABC to DEF. ABC to DEF. These correspond. So A has to go to D. Let's do this in different colors. A has to go to D. B has to go to E. And C has to go to F. Okay? To get this done, if I reflected it across this line, then my red dot would be there, my blue dot would be over here, and my black dot would be right there. So I did a reflection to get it there. Across the y-axis. Then to go this direction, I need this dot to be here, but look, the black dot's not above it. The blue dot's above it. So in order to get this that way, I'm going to rotate 90 degrees, and that is counterclockwise. So there's my combination. Reflection across the y, rotate counterclockwise. Alright, let's look at these proofs. These are the answers. So, given triangle AB inscribed inside of the circle K, so that AB is the diameter, prove C is 90 degrees. The key here is drawing this point, and this is K. That line right there creates isosceles triangles. That is the key to this entire proof, is creating isosceles triangles. You don't have isosceles triangles, you don't have this proof. Because they're isosceles, those angles are congruent, and those angles are congruent. The base angles of an isosceles triangle. Angle C is 1 plus 2. Since angle C is angle 1 plus angle 2, I can say it's angle A plus angle B. Angle C is angle A plus angle B. Now, since angle C is angle A plus angle B, when I do the triangle sum theorem for this whole triangle, so go on the next line. Since I do the triangle sum theorem for this whole triangle, A plus B equals C.
Since A plus B equals C, then that gives me C plus D is 180. Simplified to 2C is 180. Divide by 2, C is 90 degrees. All of that is possible because of isosceles triangles. Isosceles triangles is the key to proving that proof. This proof here, you're trying to prove that ABC is bigger than ACB. You're trying to prove that this angle is bigger than that angle since this side is bigger than that side. How do you know this AC is bigger than AB? Because that's how they drew it in the given. To do this, you need to draw a line again and create an isosceles triangle. These angles are equal. This is an exterior angle, which means angle 1 equals 2 plus 3. But angle 4 equals angle 1 because it's isosceles. Therefore, since 1 equals 2 plus 3, 4 also equals 2 plus 3. Angle B is angle 4 plus 3. And angle 4 is angle 2 plus 3. You then do a little bit of manipulation, and you see since angle ABD plus DBC is bigger than ABD minus DBC, right here you have the same angles, and on the same exact angle you're going to add a number and then you're going to subtract the same number. Obviously, adding a number is going to make it larger than subtracting a number. So back up here. Angle B is 4 plus 3. Angle 4 is 2 plus 3. So if I subtract a 3, B is 4 plus 3. If I subtract this 3, then I get 2 is equal to 4 minus 3. So here's the number plus, number minus.
Sean, please report to the front office if you are the one that's supposed to meet another student about a bicycle. Your name is Deshaun and you're supposed to meet another student about a bicycle. Please report to the front office.
Alright, angle B is ABC, this angle. Angle 2 is this angle. Therefore, since B is 4 plus 3 and 2 is 4 minus 3, 4 plus 3 is bigger than 4 minus 3, therefore B is bigger than 2, or B is bigger than C. There's the proof. Message me if you don't understand anything. You have the review, and I will respond.